Welcome back, physics fans, and here we go again for another static equilibrium question number 11. This is for physics 12, chapter 1 on static equilibrium. The crane assembly shown below in the diagram consists of a uniform 4-meter beam that's 4 meters long, that's 65 kilograms. Okay, they don't call it a beam, they call that a strut here, and a restraining cable. What is the maximum weight, W, that can be supported by this crane if the maximum tension in the restraining cable, that's this one up here, is 2,400 newtons. So this can only be, oops, let's get to the red pen, 2,400 newtons. Okay, and the vertical one supports whatever load you put on. So we don't have to worry about the tension of that one. So initially, we draw a free body diagram. So I'm going to do it right here, and there's the hinge here. We don't know what direction the force is. I won't do that just yet. There's a center of gravity, force, center of gravity. There's a force down here of the weight. And then there is a tension here. And that's the tension of the restraining cable. I can't draw a straight line there. Anyways, restraining cable, I'll just go RC. Okay, now I look at that, I'm pretty sure that this beam is being pushed into the wall. If all of a sudden this became a glass hinge, or I remove the wall, which way would that beam go? I think that beam would be flying down that way because this is going to push down there. So if that's the way it's going to go, my guess, it's probably that. Now, I could be wrong. It could be more horizontal, but I'm pretty sure it's not into the wall. I'm pretty sure it's not that way, because then there would be no forces that way. So I'm pretty confident it's that, but it doesn't matter. Why? Well, there's my free body diagram, and I'm going to not mess it up, but this one I will mess up. Okay. So a horizontal here is 40 degrees. So that means this angle here is 50 degrees. It's a right angle triangle. Okay, same if I did it up top there. That means this angle here is also 40 degrees. And if I have a center of gravity going down, then that is 50 degrees. Angles to the vertical are 50 degrees. So this weight here is also at an angle of 50 degrees. And this tension is at an angle of 70 degrees because it's 30 and 40. I should probably have drawn that a little bit higher up, so let's just undo those things a bit. And that's 70 degrees, not 90. This is the force of the weight. This is the force of the center of gravity. Okay, there's the hinge here, and that's where I'll be putting the pivot point, because I don't know anything about that hinge force. I guessed. So we'll leave that alone. Now we know the distances. This crane is, or strut is 4 meters. So this distance here is 2 meters. The whole distance, all the way down to that pivot point, that's 4 meters. So we have got all the measurements. We start going with the sum of the torques equals 0 when the pivot point is at the hinge. The torques clockwise is equal to the, or counterclockwise, I always do counterclockwise, is equal to the torques clockwise. It doesn't matter which one you do first. Okay, and trying to envision it, some people have that problem. There's the pivot point. I stick a pin in here, and it's pinned there, and I apply a force. That's going to make it go that direction, which is counterclockwise. All the other forces, the cog and the weight, will be clockwise. So this is going to be the tension, because the torque formula is torque is force times distance times the sine of the angle. And that sine of the angle is between that force and that distance, or the radial arm, the length of the radial arm. So this is tension of the restraining cable times the distance times the sine of the angle is equal to, ooh, I skipped the line, didn't I? I usually like kind of saying what torques am I adding up. I did it verbally, but I didn't do it in my writings here. So let's just change it to red because I'm going to insert it. This is going to be the torque of the restraining cable is equal to the torque of the cog plus the torque of the weight. Okay, back in there, so we have the FCOG, force of gravity on the center of gravity, and the distance to the center of gravity to the pivot point, and the sine of the angle, plus the force of gravity of the weight, times the distance to the pivot point from where the weight is attached, times the sine of the angle between those two vectors. And the only thing we don't know here is that, the weight. We have the rest. Let's show you by changing into blue perhaps. And this is 2400 newtons. The distance to the restraining cable is 4 meters. And the sine of the angle is 70 degrees. 70 degrees from that. So this is going to be the sine of 70. And that equals the force of gravity of the center of gravity. Okay, well, it's 65. So, I'll just do it in the calculator. I'll just go, I'll do it here. 65 times 9.8. The distance to it is, center of gravity is 2 meters. And the sine of the angle, it's 50 degrees. Okay, and now the weight, I'll do that in a slightly different color. Let's do it in green. And the weight, that's what we're trying to calculate, W, times the distance. It's at 4 meters along the whole beam, right up to there, and it is in an angle of 50 degrees. So now it's just math. Let's calculate the values. So 2400 times 4 times the sine of 70, 9,021.0 Newton meters. Now let's do the torque caused by the center of gravity. That's 65 times 9.8 times 2 times the sine of 50. This is 975.9 Newton meters plus, and then this will be a W. I'll change that just to a red. Go back to green. And 4 times sine 50. 4 times the sine of 50. is 3.064. So I take 9,000, subtract the 975, whatever that number is, divided by 3.067642, and we get W. And at this point, let's put it all in red. Let's do the math. Take 9,000, subtract the 975. That's 8,045. That is the torque caused by the weight. That's the maximum torque that couldn't exist without breaking that cable. And that's what equals W times 4 times sine 50. So then I just divided by 4 and sine 50, and I get that the weight maximum is 26 newtons. Okay? And that's the maximum weight. It didn't ask for the kilograms, so we won't ask for the mass. Okay. Thank you very much, physics fans, and see you on the next video. Don't forget to smash that like, leave your comments below, subscribe, turn that little bell dingy on there, and all that type of stuff that all those guys say. Anyways, enjoy. Physics is fun.